not just happen faster, but in the cloud with everything set up thanks to even NIMS, right?
Correct.
NVIDIA inference microservices.
Every product that you use today has some form of generative AI. So do you want to stick to just one AI app, or just do you want to use generative AI within all the existing apps? So there are two stages in any LLM development pipeline. One is in training, and the second is inference. There's multiple steps in order to optimize a large language model to be production ready.
So hello everyone, today we are in NVIDIA office again. We have Jay here, who is expert in LLMs at NVIDIA, and we will be talking about what he thinks about the switch in the workforce, especially for engineers who are, trained for years and years in data structures, algorithms, to prepare for big tech. There's an industry, how we can evolve and prepare the engineers who are spending their full 100% from the age of 18 to 22 to give their best in their college and to learn the best technologies, and especially a lot of coming in AI at NVIDIA NIMS, lot to break down. So hi Jay, can you please introduce yourself?
Sure. Hi Harnoor, hi everyone. My name is Jay. I am a developer advocate at NVIDIA focusing on large language models. So my job is to educate developers on how they can accelerate LLM workflows on NVIDIA GPUs. So my background is in computer science. So I did my undergrad from University of Pune in computer science, and then came to the States for my master's in computer science with a focus in machine learning. So I did a couple of internships at startup, and before coming to NVIDIA, I was doing a research internship at BMW doing computer vision and deep learning. So where I got to use NVIDIA software, specifically it was called DeepStream. So basically accelerating video-based, vision-based computer vision on GPUs. And I also got to try out the NVIDIA DGX station. So it's a workstation that includes 4 workstation level GPUs. So based on that, I got to interview at NVIDIA. It went well, and I started as a product marketing manager for deep learning software. So I did that almost for 3.5 years, working and launching deep learning software. So that was fun. So I got to see the marketing side of software, and I also got to work on keynotes where our Jensen, or CEO of NVIDIA, Jensen, tries to showcase the latest and greatest at the NVIDIA's flagship conference called GPU Technology Conference. So, but I wanted to be more hands-on and more teaching oriented, so that's why I took this role where I get to do some fun stuff.
And I really want to get to know you. Mm-hmm. What are your goals here at NVIDIA career-wise?
Correct.
What do you think about what's happening? What are you catching up to in LLMs, Gen AI?
Correct. Yeah, talking about goals. I am a passionate tech enthusiast. I like tech, so I grew up watching all the keynotes. So working at NVIDIA, that was one of my goals about how the keynote cycle works. So I got to be part of it. So that was fun. But throughout the process, I was working as a product marketing manager. I was trying to see how can I communicate the new features to developers, and part of which I was trying to come up with various strategies like, will a blog or a video help with understanding this feature well to a developer? I felt like I could be an educator as well, and that's how I switched from product marketing manager to developer advocate, where I get to do all those stuff, which is teaching through creating blogs, creating technical videos, and then going into conferences, giving technical talks and teaching how a technology works and how I can help them.
And your blogs have reached and have been cited in top research papers now.
Yes, yeah. So that has been my main motivation about educating developers and researchers on how they can make their pipeline or research better by using NVIDIA GPUs.
How did you figure out your passion for LLMs and how you got good at them?
Correct. So I think the passion for deep learning started in my undergrad. So back then there was a course called self-driving car nano degree from Udacity, and I was super passionate about deep learning because it was magic back then. Like understanding what's in the image, that was great, and taking it to a step further, understanding how self-driving cars work and what are the algorithms behind it. And it was mostly computer vision, core computer vision, and deep learning. So that was my motivation, and I enjoyed that aspect because it is also some form of art as well, like figuring out like what should be the learning rate of a deep neural network and things like that. So that was fun for me, and that's how I got into deep learning. And then as LLM was evolving, our team was also looking for someone who could educate developers about all the great stuff happening in the ecosystem and how can they do it on GPUs. So I was like, I'm up for it. I want to do it. Yeah.
How it has evolved? What has fascinated you the most? What are you catching up to now?
I think the earlier the notion was in the market that it is based on my understanding and my opinions that models were getting bigger and better, and that was the notion that bigger is always better. But as the time has evolved, I think people are also trying to go towards a smaller model, because running big models like trillion parameter or like billion, upwards of 500 billion parameter is not sustainable on a production scale, right? So you need lots of compute, lots of electricity, a lot more money.
What are the 3 biggest things you have learned by being in NVIDIA and in AI space?
First of all, everyone here is aware about what is going in the ecosystem. Like everyone is up to date, and everyone you talk to knows about what are the latest models in the ecosystem, how are they different from each other. So everyone has a technical understanding about how these things works. The second learning, I think everyone is humble here. Talking specifically about NVIDIA, everyone is super smart, but they are also vulnerable or just try to give their best. So it inspires you in a way that everyone is giving their like more than 100%. So it inspires, and people are crazy smart here. So it also helps. Talking about the AI industry, I think it is evolving, and specifically, I like how everyone is trying to use generative AI as part of their daily life. I can give an example of mine. So day to day, I use a lot of generative AI. I don't think so I can go back to the earlier world pre-LLM or generative AI. For example, we have generative AI licenses, enterprise licenses. So I try to brainstorm or just try to make progress on my scripts, or just try to see how can I make this process better by just having a chat with an LLM. Also, in my daily life, I use personal messaging apps, and they also include nowadays with integration with LLM. So it's just a tap away. That has been helpful. For example, if I need to go to a trip, I just can ask, hey, give me a packing list. Also, I drive a Tesla which has a FSD, so I can never go back driving manually or just focusing. I just try to use FSD. It's so good. So I think generative AI or AI in general has become a good chunk of my life, and I think I can't imagine my life without it.
Right, and everyone focus in AI about the future. I really want to talk about the present. Can you share what are the challenges you see right now and what problems you would like to solve being an AI, being an engineer?
Yes, I think specifically from the adoption of AI standpoint, I think people are still trying to use still trying to understand how they can incorporate AI or LLMs as part of their daily workflow. So there are tons of tools for developers like co-pilots for improving their coding workflow or coding pipeline. But I think people are still experimenting. Nobody has come to a conclusion that, hey, this is the best LLM, this is the best product to accelerate your coding. So I think same with, I feel like companies are still trying to understand how they can use generative AI as part of their product and also empowering their workforce. So I think it is still work in progress. I think maybe next year we might have better understanding about how this goes. So just my understanding or just my intuition.
So it's a very open field. There is like, no set path created for
Correct.
one problem.
Correct.
You have to figure out, you have to, it's a cat and mouse game, right? As people say.
Yeah. I think every product that you use today has some form of generative AI. So do you want to stick to just one AI app, or just do you want to use generative AI within all the existing apps? So, but they don't share context with each other, so that also might be a problem. But I think, we are still figuring it out. Yeah.
Excellent. So you have worked on the product side, engineering side, and you were in machine learning, computer vision from the beginning.
Correct.
So can you share what is the difference between machine learning, deep learning we used to do before the LLM era versus now?
Correct. That's an interesting question. I think the deep learning era started with computer vision, and that is where I think NVidia GPU were explored, or I think it was known that it works well with the AlexNet introduction. So I think before LLM era, there used to be a lot more work around creating your application. For example, if you had to create a chatbot, there had to be much more work that needed to be done in order to fine-tune the BERT model, model from Google.
Break it down.
Yes. So BERT. So if you had to create a chatbot, you had to first, if there's a response from a customer, so you had to understand the text by breaking it down, by removing all the stop words, like the unnecessary words which computer doesn't need to know, like the, in. So you need to remove those. Then you need to understand the intent about what the intent about that phrase is. So there was entity classification models that were done, and based on that you were coming up with a use case which was structured, or which was just one of the 5 use cases in a customer service chatbot. So that is how the pipeline worked. But with the introduction of LLM, it just knows so it understands the language so well that it can just directly answer like what is the use case that customer is looking for. So you don't need to do all the pre-processing that was needed to be done in the pre-LLM or transformers era.
And we have sped up to a level that, those pre-training can now not just happen faster, but in the cloud with everything set up, thanks to even NIMS, right?
Correct.
NVIDIA Inference Microservices. That's the latest, greatest that NVIDIA released 2 years ago. I watched the keynote.
Correct.
Big fan of Jensen Huang.
Yeah.
How simplified explanation he gave of NIMS.
Correct.
How would you explain NIMS to the audience who are engineers?
Correct.
And who don't know anything about it?
Yeah, that's interesting. And I went to the keynote, saw it live. It was amazing. Just that. But so there's two ways. So there are two stages in any LLM development pipeline. One is in training, and the second is inference. So training, for training, NVIDIA has NEMO, which we'll talk in depth later. But focusing on the inference aspect, inference is difficult, or deployment is difficult. And the reason being is, so all the models that you get, for example, model from Llama 3.1, the latest model. So they have open weights available on Hugging Face. But you cannot just take those model weights and start inferencing. It is good for just a proof of concept or a demo, but at the production scale, it's not good, because running that model would not get you the throughput that it requires for any production use case. So all those models are in FP16 precision. So there are various precision available in deep learning. So one of them is FP16, which is floating point 16. So what does that mean is the number that are stored and computed are in floating point 16 precision. So it is a 16-bit. It would have like decimal level numbers, which would be computed also during matrix multiplication. And the problem with that is it is good for foundational model training or building, but it is not good for inference, because it requires much more compute at the inference side of things. And to tackle that problem, the usual method is to do quantization, basically converting all the FP16 weights and activations to a smaller precision. In this case, it could be integer 8. So it is integer only and 8-bit. but you lose the decimal numbers in int8 representation. But there are various ways you can preserve those numbers or preserve the quality or the accuracy of the model by doing various kinds of techniques. But the upside is now you are not doing decimal computation, so it is a lot more easier. And the numbers that are being computed or calculated in matrix multiplication, it's just integer only. So think of it like 7, 8, 9. So multiplying 7 into 8 is much easier than multiplying 7.123 into 8.634. So that's an example. So that is one of the optimization that you can do to make the model run faster. And then there's other optimization. So you see there's multiple steps in order to like optimize a large language model to be production ready.
For inference.
For inference, right. So NIM tries to make that process simpler by making it easier or making it automatic for the developer. So NVIDIA, the full form of NIM is NVIDIA Inference Microservices. So the idea is to you can basically get a microservice optimized container for any open source model that you can find on build.nvidia.com. So I think there's two ways to access NIM. So one is you can basically get or generate an API key like OpenAI, and then basically use an open source model which is optimized and running on NVIDIA's cloud hosted infrastructure. So for a free user, I think you get 1,000 credits or 1,000 API calls. For if you have an enterprise account, or work email, you get 5,000 credits. But if you want to run that locally on your GPU, so there's also a Docker container, which you can basically follow the instruction on build.nvidia.com and just download it. So once you download the Docker container, it starts executing. It notices what is the hardware that you are running. So is it Ampere-based A100? Is it Hopper-based H100? And then it tries to download the optimized model for that specific hardware for your system. And once it is downloaded, the model is then hosted for inference, and it gives you out a API endpoint which you can hit to get inference requests or inference queries back. So it is and it is easy to accommodate or just integrate that into your existing pipeline because it has an OpenAI API compatible server. So if you are using OpenAI API, you can just try switching with NIMS and you should be good to go.
So let's say a company X,
correct,
they buys NVIDIA hardware H100.
Correct.
There is a lot of training to use that hardware, which is $30,000.
Correct.
Lot of training needed to use that hardware for any model for inference.
Correct.
And to do it locally on that hardware.
Correct.
Because you want to keep the data private.
Correct.
Now, that has become easier with using the NIM microservice.
Correct.
And now with that architecture, you can do it on NVIDIA's website on the cloud and have it ready, API ready, model ready, and you can use it privately there. Is that right?
Yeah, and it is all optimized and developer doesn't have to do anything. So it brings the deployment time from weeks to several minutes in some cases or just days. Yeah.
Excellent.
Yeah.
And what future you think it has changed for companies in terms of profits and in terms of employees needed to run a company?
Correct. That's a good question. So in that case, I think it helps employees spend less time optimizing and just more time in iterating model and just deploying it. So the reason being, if you are just using the traditional way, which is good. If you have a really huge scale and any inference time saved or latency time saved brings you millions of dollars, then it makes sense to spend more amount of time in optimizing your model for your own use case. But if you are just using open source models, then you can just use this, brings the deployment time significantly, and I think makes them more productive and being more iteration heavy than just spending so much time on a single model optimizing.
overall, for developers, it is saving a lot of time because let's say at the end of the day, LLMs are just like math multiplication. Let's say linear algebra multiplication or, matrix multiplication.
Correct.
Earlier, if there are two matrices, like 3 by 3 matrix, 3 by 3 matrix,
Correct.
2 multiplied in two functions, a times b, 8 times 7 and 6 times 5.
Correct.
Both happening in a different function. Now both can happen in the same function.
Correct.
In a simplified way, like forgetting about the floating point. Like if it was 7.5 times 6.5, we can simplify it to 8.7. All the simplified process can happen in NVIDIA's inference microservice.
Correct.
So it saves a lot of time in compute for an engineer.
Correct.
You mentioned NEMO framework as well, which is so big part of NVIDIA's foundry. As Jensen Huang says that, data centers are the foundry. They are the system. You provide bread and butter for these LLMs to work and function. That's basically the foundry is, right?
Correct.
That's how Jensen Huang explains it. And NEMO is a very big part of it. Explain what NEMO is and how it impacts developers.
Okay, yeah. So NEMO is NVIDIA's open source generative AI framework where you can build, develop, and train, fine-tune speech AI, language-based, and vision-based models. So it covers everything in the training aspect. So and NVIDIA GPUs are a first-class citizen, or this library is built for NVIDIA GPUs. So all the things that you do as part of LLM development is GPU accelerated from end to end. For example, there are multiple components of NEMO framework. So first is NEMO itself, which helps with training. But then there's also NEMO Data Curator. So if you are trying to build your own custom large language model or build a foundational model or just trying to generate a data set for fine tuning, you can use NEMO Data Curator, which helps you generate data set and process all the information from which is internet scale kind of data, and it is all completely GPU accelerated, and it is powered by Rapids CodeF. So Rapids is GPU accelerated suite of libraries which includes GPU acceleration for pandas, scikit-learn, and all those.
PyTorch.
PyTorch. So PyTorch is covered by CodeNN, but Rapid is specifically for data science, and data is mainly data science, like how can you do data processing on tabular kind of data. So that was NEMO Data Curator. NEMO also contains NEMO Guardrails, which is important nowadays. So Guardrails is an open source library which helps you add guardrails to your LLM application. For example, it will make sure that your LLM application doesn't go out of the boundaries or a set of boundaries that you have created for your application, or it is making sure the response is toxic or it's not toxic and there within the guidelines that you have provided, or not. It also makes sure that the answers generated are within the context that the question is provided. So that was NEMO Guardrails. Then there's NEMO Customizer as well, which helps you do the fine-tuning aspect. So there are tons of good components that you can use to build and train large language model. And of course, for inference, there's NVIDIA Inference Microservices or NIMS.
Lot to unpack there. So let's say an engineer, a developer wants to, use an existing model. How NEMO helps, in simple words?
Correct. That's a good
step by step. Yeah.
That's a good question. NEMO checkpoints, or the models that are trained with NEMO have a different specification. So I think the model trained with PyTorch comes with .pt kind of checkpoints, whereas model trained with NEMO comes with .NEMO. So it has different kind of training mechanism. So it tries to make sure that you are using all the GPU resources that are available at your disposal, including various kind of parallelism. So if you have multiple GPUs, so how can you parallelize the training mechanism on multiple GPUs? So you don't have to work through, whereas with other frameworks, GPU is supported, but you need a lot more expertise in order to parallelize that workload throughout the data center or the multiple GPUs that you have.
And you provide this on NIMS as well?
So NIMS is mainly for inference workload, whereas NEMO is mainly focused for training and fine-tuning large language model.
Okay.
So like starting from data processing to build for foundational large language models to fine tuning or customizing your model for your specific use case, which could be enterprise based or your customer related. Yeah.
Excellent. So NEMO accelerates the development of new models.
Correct.
And NIMS accelerates how you process data and inference quickly, as quickly as possible.
Correct. Yeah. So think of training is you can accelerate training with NEMO and inference with NIMS.
Excellent. And I really want to ask you about fine tuning. You mentioned that fine tuning is accelerated with NEMO, right?
So basically, what happens in fine tuning is you provide a set of responses. So question and answer. You create that data set and try to create a layer on top of existing open source model and try to influence the weight in such a way, weight and activation layer in such a way that it learns like what are the question and answers and what is the correlation between them. So it tries to understand कि जैसे jargons होते हैं हर company में, right? तो अपना foundational LLM नहीं समझ पाएगा कि वो jargons क्या है, but with the data set that you have provided with question and answers, it learns that and it can answer the question directly. Whereas with, I think the other option is using RAG. So, but with RAG, the LLM has to understand what the whole context or the whole document is about, and then come up with answer.
I see. What do you see in 20-year-old engineers who want to be part of your team in AI? What skills you would like to see in them?
I think LLMs or generative AI has become so good nowadays that you can solve any problem by just chatting with that AI. So, which means that you lose the motivation to understand what is happening, like how does the neural network work, how does learning rate impact the model training process. So things like that. I feel like people or students should spend more time understanding what goes behind the scenes or what are the foundations of large language models. And there are tons of courses available out there from NVidia, from other platforms like deeplearning.ai. So I recommend taking those courses and really understanding like what's the math behind it, because I've seen some people don't like the math and just shut off learning AI or deep learning and then go to software engineering. So, but I think that is helpful to understand how models works. That impacts your model usage or how you fine tune the model or how you engineer the prompt in such a way that you get your desired results. If you don't have that understanding, then it makes it hard at the later stage when you're doing the job. Then you might need to just go back and learn that again. So I would focus understanding the basic or the foundation before just jumping on it.
What technical skills you would want in them, in the young engineers?
Okay. So that's a good question. I think awareness of all the tools, open source tools available out there, like PyTorch, Hugging Face, you should know how to use them. And if you want to train a model, what tool would you use? If you want to fine tune a model, what are the techniques to fine tune, and what are the frameworks or libraries are out there to use to do the fine tuning process?
Can you name some?
Yeah, so for fine tuning, you can use Hugging Face. It has a tool called LoRa. I think there's a function called LoRa. For NVIDIA also has a NEMO customizer within NEMO framework. So then that was that. And then for training, you can use PyTorch. I think you can use Hugging Face as well. NEMO, of course. So I think there are tons of tools. I think first having awareness and then maybe pick one out of all the available tools and then trying it out on your own data set, or just try building a demo project in order to learn all this stuff.
What projects you would like to see in the resumes that you will hire for AI teams? Okay.
That's an interesting question. So I don't like generic projects like LLM chatbots or RAG. I feel like those are easy to reproduce or recreate. Anyone can do it after taking a course. I feel like people or students should try to look a problem in their daily life that they have been facing and try to build a solution using LLMs, and then maybe just come up with a project which can live on GitHub.
What would you build if you were in their place, 22-year-old?
I feel I would like to create a chatbot like Her, which has Her.
Like the movie Her, the most popular,
Yeah. Not the romance aspect, but just managing the daily life. Like today is my appointment with my physician, or an appointment with my optometrist. So things like that. The AI should be able to like remind me that, hey, I have a flight tomorrow, so please check in. Currently, I think those tools are there, but these are disintegrated. Having one single tool or one LLM which has the context of your calendar, or maybe what are the upcoming appointment trips and things like that. So that might be a fun project, that I would work on.
Excellent explanation of what students should make. I think Her project is definitely doable in today's world with the resources. Now, how you got good at LLMs and how you became LLMs expert at NVIDIA?
Correct. So I already had a deep learning background through my undergrad.
In Pune?
Yeah, Pune. Yes. So not specifically from the university, but I was doing courses on the side. And also coming to the States, I did my master's in CS, but it was focused on ML, and I got to do a bunch of internships throughout my time. So it was all deep learning. So I had my deep learning basics covered. But for LLMs, I think it wasn't that hard going from deep learning to LLM side of thing, because I already had the understanding of transformers, mainly coming from BERT models. But it was just a little different in the LLM space. So I took a bunch of courses available out there, like Student Word from Coursera and other learning platforms. So that was my introduction, and as I was ramping up, I did some projects, tried to understand how all the tools work in the ecosystem, and just tried running those on GPUs. So I did nothing. Basically, took the examples that were given in the courses or in the GitHub repositories from the tool makers or library providers, and just run them and trying them on GPUs. And
What's your most impactful work in LLMs that defines you as an expert?
Okay, that's an interesting question. Okay, so I recently worked on a multimodal AI RAG project. The video is live on NVIDIA developer YouTube channel. So if someone wants to go in and see how it works, so feel free to. But so it basically creates a multimodal AI RAG pipeline or RAG agent, which can answer questions based on your PDF, PowerPoint presentation, which can include charts, plots, images. So it extends RAG with multimodal capabilities, ingesting all various kinds of PDFs, PPT, PowerPoint presentation. So
excellent. I think RAG-based pipelines had been very limited. It was just text-based, and multimodality is excellent. And what else, if you'd like to name?
So I am working on a few more projects which I can't name, but stay tuned.
What future you see with LLMs and RAG-based systems right now?
So I feel like RAG will evolve with, of course, the new direction is multimodal capability. I think there's a ton of research going on there. The other thing with RAG, I feel like the smaller models will be much more useful. So as the models are getting smaller, it is easy and efficient to run RAG pipelines. So if model is good at reasoning, I think that should be good enough to connect with the external data source or database and get the pipeline running, than having a model which is big, which has the world knowledge, but in an enterprise setting for a particular use case, that world knowledge isn't relevant, right? So just using a smaller model which has good reasoning capabilities, connecting that to a large database or source data of enterprise, I think that would be a good use case. The other thing that I see is I think local co-pilots. As the model are getting smaller, there's ton of optimization that can be done and is being done, which is making them run on small devices like laptops and phones nowadays. So I think that is a good next step that we are heading into, so that we don't have to send our data to a server. You can just run the models locally on a smartphone or laptop and get the results.
What are the challenges you see in your day-to-day life in LLMs, and what misconceptions people have of you around you?
Correct. So talking about challenges, I feel like the field is moving so fast that it's sometimes hard to keep up what's happening and just trying to understand. Like, I think there was a time in 1 or 2 weeks, there was announcement of 3 or 4 open source models, and then there was also a bunch of research or techniques that was announced or released by few companies that how to make the context length bigger and better for models. So I think in that case, it's really hard to understand like what things should I focus on, or also I'm also thinking about how can I educate about one technology to our developers, right? So picking one technology out of the spectrum becomes hard, and also keeping up with it is also hard. But I think I have my setup which has been helping me. So I just try to follow a bunch of folks on Twitter and just try to see what they have posted or what's new and what's better. So that's one thing or one challenge, I think. Also, I am producing videos now. So generating or producing videos is a new skill for me. So that is new. But
your sessions, I've seen some of your sessions on YouTube. Yeah, you teach pretty well about LLMs and especially that RAG project.
I think our CEO says that you shouldn't be afraid of AI. I think you should embrace AI, which means that you should be able to, or you should try to learn all these generative AI tools, which improves the productivity of a developer or anyone using it, so that they become superhuman and be irreplaceable. So that's the thing that I follow. I think just embrace this, try to see how can I improve my workflow by using all these tools and get more productive rather than just avoiding it and being scared out of it.
The biggest misconception of any AI engineer is the fear they bring in the life of engineers. But I think, Jensen Huang says in the best way that engineers will no longer be engineers. They will become super humans or super engineers, right? Yeah. One thing I've seen in LLMs that is lacking is that, let's say I want to customize for my own use case. Let's say I have an English paper I wrote, for my students, and 50 students submitted it. Every different model, like your competitors like Meta, Google, Anthropic, they all can give different points. Some can give 9 out of 10, 10 out of 10, 11 out of 10. But if I want a system in AI, I want to give, let's say, based on grammar, I want to fine-tune it and put a criteria. If grammar is excellent, give 10 out of 10. And if, let's say, if let's say the wording is not American English and British English, deduct points. I want to make my own metrics.
Correct.
I cannot do that properly right now.
Correct.
So what you think the future is in this process-driven development? Is that in the talks right now?
So I think there's 3 ways to approach this problem. So the first or the easiest one is using prompt engineering. So what does this mean is you create a prompt in such a way so descriptive that the model knows how to grade these questions or answers by giving it a few examples about how would you do it. So if this is the answer, I would rate this as 6. If this is the answer. So you create basically a prompt before asking LLM to judge or query or just submit a assessment for a question. So that's the easiest way. But the problem with this is it is not consistent.
Yes, that's the problem.
Yeah, and the second one is you are increasing the context length of the model. So if you are running this at scale, this might become a problem. So the second one is you fine-tune the model using one of the techniques, which is, for example, LoRa. So which is very efficient in terms of fine-tuning. So you basically create a data set about responses and grade. So you create that data set and try to try to train a model with those data set and get it will give you a fine-tuned model which you can use to assess. And the third, or the most I think expensive way, is to create a foundational model from scratch just for this purpose. So I think based on this, I think the fine-tuning aspect, just creating a data set about how would you rate answers, I think that would be a better option. And the tools are available out there like Hugging Face, and it is also GPU accelerated, so you can use openly or freely available GPUs like T4. I think that would support only a certain size of model, but I think that will still get you started.
Right. And a lot of engineers watching me, they think that LLMs are expensive. NLP ways, before LLMs are still cheaper than using APIs of these large language models, because for large scales, they become still very expensive. So do you know some hacks or ways to reduce the cost per token, or like to use a prompt that uses less tokens in LLMs?
Okay. I feel like this is a prompt engineering question, and it is more art than science. But what I've seen is being descriptive helps, and there are tons of courses out there available on how you can create a specific prompt that will get you. I don't have any specific answers, but I think just try to take one of those courses. But what I've seen is being descriptive really helps. Yeah.
What security risk and threats you see while building an LLM, using an LLM, inferencing an LLM in all three stages?
I think mainly the security risk is at the deployment side. I think one of the examples is prompt injection, where you just basically ask a customer chatbot to do a non-customer service or use case, and that in some cases it answers that question. So I think it is much more recommended to have guardrails around your use case or deployment, for which NVIDIA has a NEMO guardrails, which helps you do that. But there's other open source tools available as well.
How does it work? How do guardrails work?
So you basically try to see and judge all the queries or the transaction happen between user and the LLM, and the NEMO guardrails tries to check if the response generated is within the boundaries, like it is not toxic and it is not going outside of the use case. So there's there's ton of documentation, but it just makes sure that the LLM response are generated within a guardrail or within a boundary that the application is supposed to do, and not go outside of it.
Hardware level guardrails, right?
No, so these are not hardware, these are software. So you basically write a specification about what your needs are. So there are various parameters. So there's documentation available.
So security threats are more on the inference side. So that we need some guardrails so that we can protect the answer of that prompt comes related to what you asked.
Correct.
And software level guardrails are NEMO is part of
NEMO guardrails.
NEMO guardrails, yeah. Now, any other threats you see that we need to be cautious about, or for all the startup founders watching this, or AI engineers watching this?
Yeah, I think the guardrails would be the most important thing for now. Also, I think there are various tools out there in terms of generative AI. So I think we should make sure that what kind of data is being sent to the clouds while processing, if they are keeping our data onto their servers or not. So things like that should be we should be more careful of using those tools.
Awesome. And I heard that there is an NVIDIA conference coming up in India. Can you please share details on that?
Yes, yeah. So there's a conference called NVIDIA AI Summit that is upcoming in India. It would be in Mumbai at the Geo World Convention Center, and Jensen will be there having a fireside chat. So, and there will be ton of good sessions as well, ranging from data processing to LLMs and everything in between. So I would recommend your audience to join that, and your audience will also get a 20% discount on the conference price. So that I'll share, and you can put that into the YouTube description.
Awesome. Thank you so much, Jay. It was wonderful talking to you. Learned a lot as always, and I hope this video inspires more engineers, AI enthusiasts to do development the right way. Thank you so much again using NEMO and NIMS. Thank you again.
Thank you for having me.